Hello everyone, this is Ketish here. In this video, I'm going to go through question number 2 from the AQA Combined Science 2020 Physics Paper 2 Higher Tier. Question number 2 is on forces. This question is actually on the required practical on Newton's second law. So this is testing on the required practical. Which is F equals ma, that's Newton's second law of motion. So a student investigated how the height of a ramp affects the acceleration of a trolley down the ramp. Now here you have a setup where you've got 3 wooden blocks, 1, 2, 3, used to prop up the ramp, and a trolley on the top. So if you increase the height, the trolley will actually go faster down the ramp. So how does the height, this height, which is h, affect the acceleration? Now in order to find the acceleration, I will need a couple of things. I can find out acceleration is change in velocity divided by time. So the initial velocity is 0. I can find the velocity between 2 points over here by measuring the distance. Or I can find the total distance traveled, let's say from there to there, and let's say that distance is s, and I can use SWOT equations as well. So plan an investigation to determine how the height of the ramp affects the acceleration of the trolley. For the 6-mark question, how would you answer this question? So you need to take it step by step. First of all, you can change the height of the ramp by changing the number of wooden blocks under the ramp. Then you can measure the height using a ruler, a meter ruler. And you can also measure the distance using a meter ruler. And you can time how long it takes for it to, let's say, move from A to B. You will need to measure the time, and for that you need a timer or a stopwatch. And you would repeat for each height at least 3 times, so you can actually get an average value of the acceleration. So the measurements that you would take, you can actually split this answer into 2 parts. First of all, the measurements, and then how you would get the results. So here's how you would write an answer. Vary the height by placing different number of wooden blocks under the ramp. Measure the height of the ramp using a meter rule, and measure the distance traveled using a meter rule. Measure time taken using light gates. Now you could use a light gate between A and B, placed here at A and B as well, and then connected to a data logger, and you can measure the time. Now if you've got light gates, you could literally actually use it to measure the acceleration itself straight off. So any of those methods is fine. You measure time using light gate and data logger, or using a stop clock for the trolley to move a measured distance. Now one of the key things that you need to do is to release the trolley from the same position each time without applying a force, meaning that you're not pushing the trolley down the ramp. How would you analyze the results? Repeat for the same height and calculate a mean. Repeat for different heights. So when you say different heights, you could say 1, 2, and 3 blocks height. Calculate acceleration using the equation v minus u divided by the time. So final velocity minus initial velocity, which is going to be 0, divided by the time, or you could use the equation acceleration equals v squared minus u squared. Let me write that properly. Acceleration equals v squared minus u squared divided by 2s. So v squared is the value that you would want to calculate. U squared is going to be initial velocity squared is going to be 0 divided by 2 times the distance the trolley has moved. Here we are not actually using the time, but you would still need to measure the time in order to find the velocity, final velocity of the trolley. Next part, table 1 shows the results. So here you have the height of ramp in meters, going up in 10 centimeters, 0.1, 0.2, 0.3, 0.4, 0.5, and 0.6. And you've got the acceleration given as well in the next row. Figure 2, the first two results have been plotted. Complete figure 4. You should label the axis, plot the remaining results in from table 1, and draw a line of best fit. So let's label the axis. So here you can see the x-axis is going from 0 to 0.6 here. So 0 to 0.6 is actually the height of the ramp. So this would be the height of ramp. Ramp, that's in meters. And acceleration in meters per second squared. So y-axis is going to be acceleration in meters per second squared. Now you could put that in brackets, but don't put a slash. That will mean you're trying to divide it. So you need to plot the points for 0.3, which is 0.3, 0.4, 0.5, and 0.6 there. So 0.3 is 2.1 here. So 0.3 is along this line, and it's going to be 2.1 over there. So that's 5 boxes. So from 2 to 2.5, that's 5 boxes. So each box is 0.1. And at 0.4, it's 3.2. 0.5 is 3.9. 0.6 is 4.3. And draw a line of best fit. So you would get at least 3 marks out of the 4, and the final mark is actually to draw a line of best fit. Now the line of best fit needs to start at 0. So let's see if I can draw a straight line. If I should hold it. Nope. Let me get rid of that line. Be able to now if you were to use a ruler, the line should be straight somewhat like this, and that is slightly better. So make sure that you use a ruler to draw a straight line going through 0. So the marking scheme says 3 marks. All points should be plotted correctly. The height of ramp in meters on x-axis and acceleration in meters per second square on the y-axis. Correct line of best fit for the 3rd mark. Question 2.3. Write down the equation that links acceleration, mass, and resultant force, which is F, M, and A. So the F equals ma. So here the word equation would be resultant force equals mass multiplied by the acceleration, or F equals ma. When the resultant force on the trolley was 0.63 newtons, so that's the resultant force. The acceleration on the trolley was 2.1 meters per second. Calculate the mass. So the equation F equals ma, force is 0.63 equals the mass multiplied by the acceleration, which is 2.1. So the mass is 0.63 divided by 2.1, and that gives me a mass of 0.30 kilogram. 0.30. That brings us to the end of question number 2, and I will see you in question number 3.